Not that I have any particular penchant for pentagons, but let's look at another pentagon just because the number of sides is appropriate to the problem. We want to know how many triangles there are in this figure. Now there are a lot of triangles. I mean, here's a triangle. Here, well, let's see, can we go here? Yeah, we can go here and get a triangle. We can go down here and get a triangle. Here's a triangle. Here's a triangle. Lots of triangles. You go nuts trying to trace them all. We need to be very systematic. Now there are systematic ways to trace these triangles. In other words, we could start off with this segment and see how many triangles contain this segment. But later on, when we say go to this segment and see how many triangles come off of this segment, we're going to go back and get this one, which also goes off of this segment. So each segment is going to be included in several triangles. The way we're going to do this, we're going to go ahead and label the vertices first, A, B, C, D, E. And then we're going to label these points here where the lines cross. And let's label these F, G, H, I, and J. Now there are 10 vertices, 10 possible vertices, or 10 possible intersections between the lines. And the key is that a triangle is going to be composed when you can list the 3 vertices, and that listing of 3 vertices does indeed give you a triangle. So what we're going to do is we're going to list the sets of 3 vertices, and we're going to list them alphabetically, and then we're going to see which ones form triangles. Okay, we don't want to, well, we're going to do this alphabetically because if we've got A, B, G, we don't want to get G, B, A, and G, A, B, and B, G, A. They all describe the same triangle. If we do this alphabetically, it's not going to be possible for 2 of them to describe the same triangle. So let's go ahead. We got the letters A through I. Let's see if we can systematically list alphabetically the combinations of 3 letters. We start with A, B, C, and then we'll go A, B, D, A, B, E, A, B, F, A, B, G, A, B, H, A, B, I. Now, not all of these possibilities are going to form triangles, but these are the only possibilities for triangles that start with A and go in alphabetical order. Now, we can then list B, C, D, B, C, E, bad looking C there, B, C, F, B, C, G, B, C, H, and B, C, I. And then we can start at C. We can list C, D, E, C, D, F, C, D, G, C, D, H, C, D, I. And then we'll go to D. We'll list D, E, F, D, E, H, D, E, I, and D, E, J. And then down below this, let's go ahead and start with E. We got E, F, G, E, F, H, E, F, I, E, F, J. And then we're going to have F, G, H, F, G, I, F, G, J. Then we'll have G, H, I, G, H, J, and finally H, I, J. Now we can count these, and we see that there are 1, 2, 3, 4, 5, 6, 7, and 6 makes 13, and 5 makes 18, and 4 makes 22. Something's wrong there. I didn't get D, E, G in here. So let's put D, E, F here and try to make this F look like a G. F, G, H, I, J. And I seem to have left some J's off of here. We got A, B, J, B, C, J, and C, D, J. Okay, so let's try again. Now there are 1, 2, 3, 4, 5, 6, 7, 8, and 7 is 15, and 6 is 21. This is why it's always good to go back and double check that you have a reasonable pattern. 5 makes 26, and 4 makes 30, and 3 makes 33, and 2 makes 35, and 1 more makes 36. So we have 36 alphabetical listings here. Now what we need to do is go back and see how many of these actually form triangles. Now we're not going to be able to see the whole picture. You'll be able to see a good bit of it, and you'll be able to see what's going on. I won't go through the whole thing. I'll leave that for you. But let's look at A, B, C. Does A, B, C form a triangle? Well, sure, there's A, B, C, and we can get right back to A. So that one's good. What about A, B, D? Well, sure, A, B, D works. What about A, B, E? Yeah, that works. That's a triangle. There's A, B, E. What about A, B, F? That's perfectly good. And A, B, G is a good triangle, and A, B, H is a good triangle, and A, B, I. Oh, there's one that isn't. Okay? And A, B, J, well, there's no even B, J there. See, there's no I, A, and there's no B, J. So that these last two, A, B, I, and A, B, J, are going to have to be crossed off, aren't they? Now let's see what kind of pattern emerges here. If we go to B, C, what about B, C, D? Well, that's perfectly all right, and B, C, E makes a triangle, and B, C, A makes a perfectly good triangle. And then what about B, C, F? B, C, F. Well, we don't have a line from C to F, do we? Okay, so B, C, F has to be crossed off. And B, C, G, well, that one's all right. B, C, H is fine, and B, C, I is fine. And B, C, J, uh-oh, B, C, J is no good. So we're going to have to cross that off. And then we have C, D, E, perfectly good. C, D, F, no, that's no good, is it? Because there's no C, F again. And C, D, G, well, that's no good, there's no G. But then C, D, H, and C, D, I, and C, D, J all do make triangles. Now, I'm not going to continue the list. You can do that yourself. But we'll see that we'll be crossing some off, and the ones that we have left will be the triangles that are formed in the figure. And you see that there are a lot of them. Probably going to be close to 30 of them, somewhere in the 20s. So you can complete this exercise.